wonderful SM3 peeps. We're going to start today's lesson with a sing-along. Yay! You know you want to. Okay, and we're going to sing the Quadratic Formula song. Here we go. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Good job. If you don't know that song, you should know that song. And we'll practice it in class, and you'll love it. I just know it. Okay. 3.6, the fundamental theorem of algebra. Notice that people have two eyes. Just keep that in mind, okay? Two eyes. All right, so here we have some examples of equations. So this one, 2x minus 1 equals 0. It's of degree 1, right? That's my biggest exponent. The solution to this problem is 1/2. So the number of solutions I have is 1. Okay, here's another example. X squared plus 2. It's of degree 2. It has, these are the solutions here, and there are 2 of them. Then I have, forgot to start this again. Then I have this last one, okay, it's a little more lengthy, it's of degree 3. It has 3 answers, and so, yeah, so these are the answers and there are 3 of them. So I'm hoping that you see a pattern mostly between the degree and the number of solutions. Because basically, that's what the fundamental theorem of algebra is. I'm not going to read all of this. If you want to read it, it's in your book. But what it is basically saying is the degree of your polynomial is the number of roots that it has. Okay? Now, what kind of roots they are, well, that's where it gets a little bit more complicated. Not too bad, though. So, for example, let's find the zeros of x squared plus 5 equals 0, okay? So I'm going to subtract 5 from both sides. So I have x squared equals negative 5. Well, I can't do that, right? I can't take the square root of a negative number, but I can if I use complex numbers, which are not real numbers, and this involves imaginary numbers. So in this case, x equals plus or minus I times the square root of 5. I, remember, is the square root of negative 1. It's my imaginary number. All right. The complex conjugate theorem. Remember the irrational conjugate theorem? That's the one where I showed you the picture of the conjoined twins and you couldn't have one without the other. Well, this is exactly the same thing, except instead of square roots, we're using imaginary numbers. So, if f is a polynomial function with real coefficients, and a plus bi is an imaginary 0 of f, then a minus bi is also a 0 of f. They go together. You're never going to have one without the other. Okay, so in other words, you need a pair of eyes. Get it? That's why I showed you the picture of the eyes in the beginning, because you need 2 eyes. All right, so let's look at an example. Let's see what time it is. Okay, we'll do this example and then I'll do the next couple of examples on the next one. All right, so solving a polynomial equation. So far, the lesson that we had before, we're doing this by factoring and by using the rational root theorem where we can guess at what root might be and we use synthetic division to divide it to see if it works. Okay? In this particular one, this actually I can factor by grouping. So if I group this, I have x cubed and then I have x plus 1. And then over here I can factor out an 8 with an x plus 1. So I'm left with x plus 1 times x cubed plus 8. Now, I see that I have, this is of degree 4, so I'm going to have 4 roots to this problem. Okay, hopefully you recognized that this is the sum of 2 cubes. So this is a perfect cube and 8 is a perfect cube. So when I factor that, remember, this is 8 is 2 cubed. So I'm going to have x plus 2 times x squared minus 2x plus 4. Okay, so I've got one of my roots right here, it's negative 1. I have another one right here, it's negative 2. But this I can't factor. This is not factorable, but at least I have it down to an x squared. Once you have it down to an x squared, you can use x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. We can use the quadratic formula. Okay, so in this case, a is 1. That's this invisible one right here. B is in the middle, so b is negative 2. And c is 4. So now I'm going to put it into the formula. And I'm actually going to move over here so I can be a little bit higher. So x equals negative 2, which is negative 2, plus or minus the square root of b squared minus 4 times a times c over 2a. Okay, all I did was just plug these into the formula. All right, so now this becomes 2 plus or minus the square root of, this is 4 minus 16 over 2. So x is 2 plus or minus the square root of negative 12 over 2. And if I simplify this, I have, this becomes the square root of 4 times the square root of negative 3 over 2. Okay, because I can divide that out like this. So then that becomes 2 plus or minus 2 times the square root of negative 3 over 2. And then these 2's divide, so I'm left with x equals 1 plus or minus, this negative is an I, times the square root of 3. So my roots to this problem are negative 1, negative 2, 1 plus the square root of 3i, and 1 minus I times the square root of 3. Okay? So 1, 2, 3, 4 roots. Now this next part is something that's kind of important. It'll be on the test. Well, this will be on the test, but this also will be on the test. I put it into Desmos, and this is what it looks like. Now maybe you're wondering, here I'll finish, I think it was negative 1 and negative 2. So if these are my roots, then shouldn't they cross the x-axis in 4 places? Well, they don't. Here's negative 2, and here's negative 1. The ones that cross the x-axis are the real roots. They're the ones that are real numbers. 1 plus or minus I times the square root of 3 is imaginary, so it is not in there. So if I have a problem that is a 4th degree, and I see that it looks like this, then I know that it has 2 real solutions and 2 imaginary solutions. All right, I am going to go on in the next video.